Hello friends, welcome to yet another video in a series of videos where we discuss about previous year's NEET JEE question paper. If you have not watched my previous videos, do hit that I button and follow all the videos which is all there. If you are new to my channel, do consider subscribing it. For today, we have a very special question which is taken from previous year NEET question paper. It's actually a combination of 3 different chapters, basically from plus 1 and plus 2, which has 2 chapters from plus 2 and a chapter from plus 1. If you order the chapters, we have an equation from plus 2, which is the first chapter called electrostatics. Then comes down to 7th chapter, the dual nature of matter and radiation, that is from plus 2, and a chapter from plus 1, which is force and laws of motion. My name is Naveen Kumar and you are watching my YouTube channel. Okay, now let's analyze the question very carefully. An electron of mass m and initial velocity v equal to v naught times I cap, where v naught is a value greater than 0, enters an electric field given as E equal to minus E naught times I cap, where obviously E naught is greater than 0, which is mentioned here, at time t is equal to 0. That means these are initial time conditions. So lambda naught is the de Broglie wavelength initially, then its de Broglie wavelength after a time t is. That's the question we have given with 4 options: lambda naught time t, lambda naught into 1 plus E naught by m v naught time t, lambda naught divided by 1 plus E naught divided by m v naught times t, and the 4th option is obviously lambda naught. Okay. This is one of the most beautiful questions which have come in previous year's NEET question. If you like this question, please hit that like button and let's proceed. Let's write down the initial conditions or the values which are specified in the question. The values are: the initial velocity is given as v equal to v naught times I cap, and electric field initial value is given as E equal to E naught times I cap, but with a negative sign. Okay, and then lambda naught is given. What is the lambda naught? Lambda naught is the de Broglie wavelength, which is given as h divided by m times v naught. Since I believe that you have already gone through the chapter called dual nature of matter and radiation, where it is specified that the de Broglie wavelength of the matter wave is equal to h divided by m times v. Here it is lambda naught, so that we can write it as h divided by m times v naught. Okay, that's the specified quantity which we already know it. Now as we proceed on, it is mentioned that it is an electron, and as the electron is having some velocity, with an initial velocity is mentioned. Anyway, if an electron is having a mass and it is moving through an electric field, it will experience a force which we have already studied in our chapter called electrostatics. So what's the equation? The equation says that the force on the electron will be equal to Q times E. I can write this equation as minus E, which is the charge of the electron, multiplied by the electric field, which is already given in the question, which is minus E naught times I cap. So what will be the force acting on it, which is equal to E naught times I cap is the force acting on the electron. Now if a force is acting on the electron, I can write down the acceleration which is felt on the electron. What's the acceleration? Acceleration A is equal to the total force divided by the mass of the electron. Okay, right. So that we can write this equation as E naught divided by m times I cap. Right? So this is the acceleration which is felt on the electron. So what will be the velocity of the electron after a time t? What you can do? We can apply Newton's equations of motion. Newton's first equation of motion to be precise. What's the first equation? It shows that velocity after a time t is equal to initial velocity plus acceleration multiplied by time. So what we can do, we can substitute the initial velocity, which is already given in our question. So the initial velocity is v naught times I cap, plus acceleration is also, we could have found out from here, so that it can be written as E naught divided by m times I cap, or probably before I write I cap I could write it as T into I cap, so that I can write giving you V naught plus E naught divided by m times T into I cap, which is the equation for velocity after a time t. So the wavelength or the de Broglie wavelength after a time t can be written as lambda of t is equal to h divided by m times velocity after a time t. So that if I substitute these values, I could get h divided by m times the equation for velocity we have already got from here, so that we can write this equation as m into v naught plus e naught divided by m times t into I cap, or probably I don't need to write it, into I cap, which I don't need to write down the equation for I cap. So that I can write this equation as h divided by m into v naught into e naught divided by m into t. So what I can do is I can take v naught outside as common, so that what you will get is h divided by m times v naught into 1 plus e naught into t divided by m times v naught. This is the de Broglie wavelength after a time t. So if I can write down this equation equal to h divided by m times v naught, we have already assumed it as lambda naught divided by 1 plus e by m v naught times t. This is the final value we need to get. Let's look at the options. Which are the options? The options given in here as these. So among these answers, we have already found out the answer, which is the third option. Now I believe that you understood it. Let's analyze which are the equations we have gone through. We have gone through the chapter and the equations which is connected in the chapter called force and loss of motion, and it is also an equation from electrostatics. Also we have covered a topic, an equation, the most important equation, which is the de Broglie wavelength connected to dual nature of matter and radiation. I believe that you understood it. If you like my content, please hit that like button and share with all your friends, so that everyone gets a benefit out of this videos. With the next new question, see you later. Bye.